Welcome back, mathematicians. At this point, we're going to talk about rational exponents. And by rational, what do I mean? Okay, so rational exponents are going to be fraction exponents, right? We've dealt a lot with whole numbers or integers. Now we're going to talk about rational exponents or fraction exponents, okay? So let's look at this first example here. Let's try to simplify it. There's a few ways we can go about it. We could start by, let's start by combining these two terms, right? So we already know some of our fraction rules. If we're multiplying the bases, we can go ahead and add the exponents. So I have 3 halves plus a negative 5 halves. And again, on the outside, I have a negative 1/3. Okay? So what I should do is add those together, right? So positive 3 minus a 5, basically. And I'll get 11 the negative 2 over 2 to the power of negative 1/3. Okay, so I haven't had to deal with too much rational exponents yet. That would just simplify a little bit more to 11 to the negative 1 all over, or to the power of negative 1/3. Okay, so next what I want to do is simplify this guy a little bit. I'll have, actually, now I can use those same rules as before, right? I have a negative 1/3 as a power on the outside. So if I have some base to a power, then I multiply, or sorry, some exponent to a power, I multiply those two exponents. So I'll have 11, right? And then I'll have negative 1 times a negative 1/3, which would give me a positive 1/3. So again, a negative times a negative is going to give me a positive. So positive 1/3 is my power. So if they want it in, this is a perfectly fine answer, but if they want it in radical form, you'll have to go that extra step and convert it to radical form. There you go. So that is one answer. It's not bad. Let's scroll down a bit. Let's look at a second example. Okay, so I have a lot more stuff going on here, but I'm going to handle it pretty much the same way. One thing I noticed is that I don't have the same bases, right? So I want to change my bases to be all the same. Okay, so let's do that first. Think about what could be a base, right? So in my head, I could see that this is 3 to the third power, this 27 is 3 to the third power, and this 9 is 3 to the second power. So I could have 3, 3, and 3, so that's what I'm going to go with. So that one doesn't change. That one already has a base of 3. I have 3, again, 3 to the third power, check it. 3 times 3 is 9, times another 3 is 27. Okay, and 3 squared, I'm converting that 9 into a 3 squared. Okay. And then that's going to give me, let's see here. I'm going to have to simplify these guys again. So again, I have 3, 3/4. Don't change that at all. I'm going to multiply these things together, right? So I'm going to get 3, and then I can convert that to a fraction if I want. 3 over 1, multiply by 3 over 4. That's going to give me 9 over 4. And again, if you need scratch work, this is what I'm talking about. 3, 3, 4. And that's going to give me 9 to the 4th. All right. All over. And again, I'm going to multiply these two. So I have 2 over 1 times 3 over 4. I'm looking at these exponents right here. So I can reduce this to 1. Oh, sorry. This is reduced to 2. This is reduced to 1. There you go. So I have 3 times over 2. So I'm going to have a power of 3 halves right there. Okay, so now I can use my same exponent rules. If I'm multiplying my bases, I know that I can add my exponents. So let's do that. 3 to the 3/4 plus 9/4 over 3 to 3 halves. And again, I'm just adding these exponents because the bases are the same, which is going to give me 3. I can add those because they have a common denominator. So it's going to be 12 fourths all over 3 to the 3 half. That's going to give me 3 to the 3rd power on top. And then I'm going to subtract 3 halves. And then, sorry, this is getting so jumbled up here, but I'm going to convert this fraction. 3, I'm going to find a common denominator, right? So I'm going to have 6 over 2. Yep, that'll give me 3. Minus 3 over 2. So again, I converted this guy to make this guy. So my answer is going to be a 3 to the 3 over 2. And that's an okay answer. If we want to make that a radical form, we could do that too. I have the square root. Oops, I have a 3 square root and 3's inside of there. Okay, 1 and 1/2. Yep, that works. So that'll be my answer. Okay, so again, review your conversion, your radical rules if this doesn't look familiar, and I'll catch you on the next video.